1 second. Yes. See here. So last class, yes, interpreter and compiler difference is discussed. Difference between interpreter and compiler last class cleared. Interpreter and compiler. See main difference. Interpreter exe file does not generate exe file. Yes, compiler generates exe file. See, interpreter based language don't have exe file. Yes, in compiler based everything converts in exe only. Exe file is a main difference. Exe file is a main difference. Okay, so this is about interpreter and compiler. Now, let us see about Java. Yes, about Java. So about Java. Okay, today about Java. See, except Java in other languages, what happens here? Except Java in other languages like C, C++, Python, HTML, maybe Perl scripting, different languages. What happens here? So first of all, source code converts into binary code. Source code means your program is a source code. For example, this is C program source code. C program source code. Okay, that source code converts into binary code. After converting the yes, I'll show binary code also. Today I'll show binary code also. Source code converts into binary code. That binary code given to processor, finally generating outputs. So that's a case of except Java, other languages. Okay, when you come to Java here, Java first of all source code converts into byte codes. That byte code converts into binary code. Yes, given to processor generating output here. So in Java, byte codes introduced. Yes, there's a intermediate code, byte code. Yes, why this byte code was introduced here? To make the Java as independent. To make the Java as independent platform, this byte code was introduced here. To make the Java as independent platform, that byte code was introduced here. That byte code introduced. Okay, right? Yes. So here this is in 2 steps. Source code to byte code. See, source code to byte code by the compiler, Java compiler. So this is by the Java compiler. By the Java compiler. Just a minute. Yes. Source code to byte codes by the Java compiler. Next, byte code to binary codes. Yes, by the Java interpreter. Yes, let me show practically. See here, D drive, support test folder. Suppose here I'm writing Java program. So actually here Java program development every day our class is using Eclipse. Yes, using Eclipse. Okay, I'll be using Eclipse every day here. Yes, today just for understanding purpose, I'm using Notepad. For understanding purpose, I'm using Notepad. Okay. See, D drive test. Yes, D drive test folder. In this, we develop one program using Notepad. So first of all, go to command prompt. 1 second. Today just we are discussing about how Java is working, not about Java programming. Topic is about how Java program is working, that we are discussing. Okay, not actual programming. Actual programming tomorrow will start. Yes, installing Java, installing Eclipse, how to develop Java program, that all the steps tomorrow topic. Today topic about Java compiler, Java interpreter, this topic here. Okay, how it's working here, the topic. Not about Java programming. Java programming tomorrow will start. Okay, now here, first of all, we should go to this for D drive test folder. Now C drive here. Now D colon that will take to D drive. Now DR that contents, D drive contents. Here there is a test directory, test directory. Now cd change of directory, cd test changed, cls clear the screen, clear screen. Yes, miss. No files, nothing, zero files, empty. It's empty directory. Directory folder both are same. Test folder empty. Not test directory empty. Now notepad. I'm writing some sample program. Notepad test.java. Yes. So cannot find test.java. Do you want to create a new file? Yes. Okay. Yes. Let us write public class some test. Yes. Class starting ending. Next main method public. Yes. Static void. Yes. Main. Yes. String caps. String square bracket args, string array of funcs, main method starting ending. Yes. System dot out dot println. Yes. Hello world. Yes. Control yes, save it. Yes, is notepad, right? Control yes, select all. That is well known for you. Control yes, save. Control yes, save. Yes, here exit. Okay. Now dir. Yes, you can see test.java. See 8:15 p.m. Yes, 16th July, sorry, 16th June. 16th June. At this time, just now created. Now 8:15 time. Okay. Now first test.java is this is source code. Test.java. This is called a source code. This is source code. This code is a source code. Our program is source. This is source code, right? Yes, source code. Yes. Now yes, submitting to compiler. Source code. Yes, submitting to compiler. Given to compiler. So Java C test.java. Yes, I'm compiling now. So this is compilation process. Compiling Java program. Yes, compiled. After compilation, check it. Yes, tested dot class file generated. It's 8:16 p.m. Just not tested dot class file generated. So what's happened here? So first your source code test.java. Test.java is a source code, right? It's a source code. Yes, it's a source code. It's a source code, right? That source code file given to Java C Java compiler. Java C test.java. Okay, Java C test.java. So the test.java taken by Java compiler and compiling. So test.java given to Java C Java compiler. What is result file? Test.class file generated. Result is test.class file. Yes, this is bytecode. Yes, what is exactly bytecode? We'll discuss next. Wait for some time. I'll explain. So test.java given to Java C compiler. Java compiler checking for all the errors. If an errors, generating dot class file. Okay, generating dot class file, right? Okay, yes. After generating dot class file, now dot class file is ready. So dot class file, it's a bytecode file. Dot class file. Now this dot class file executing. Now what is this? It's an interpreter, Java interpreter. Now Java interpreter taken tested dot class file and executed. Okay, now here, so tested dot class file. Yeah, this dot class file. Yes, dot class file giving to yes Java interpreter. So next Java interpreter passing to Java interpreter. Okay, so test.java passing to Java compiler. Java compiler taking compiling generating dot class file bytecode. That means source code to bytecode converted. Now this bytecode file given to Java interpreter. Okay, let me have water. Java interpreter. Now Java interpreter taking that bytecode file. Yes, what is interpreter? Line by line working, right? Line by line working. Line by line not working here. Line by line working. Yes, because one second, because you are an online only. Yes, because yes, here check your system volume. I think maybe in mute system volume. Check your system. You are in online, but not audible means your system volume may be very low or maybe mute it. Check it. Maybe that's the issue. Yes, or else rejoin or rejoin or rejoin. Okay. Yes. Now Java interpreter. See, yesterday we discussed interpreter line by line, right? First line taking, converting into binary code. That binary code given to processor. So processor taking binary code, then generating output. That's it here. So this is what is happening in Java. So finally we got the hello world output, right? Now what are the steps? See this. First to write the program, notepad. See here I'm using up arrow key to get the previous commands. Up arrow key. Command line, it will maintain the history. Command prompt will maintain the history. History. See notepad. Open. Yes, first open notepad. Source codes of writing this. Next step is compilation process. Compiled. Errors checking by the compiler. Now program execution by the interpreter. That's it. Okay. So what is happening here? Yes, in Java, errors checking by the compiler. Yes, in Java, errors checking by the compiler. Okay. Yes. If no errors, it generates. Yes, it generates dot class file. Dot class file. It generates dot class file. That's it. In Java, errors checking by the compiler. If no errors, it generates dot class file. Fine. Okay, right? Next program. Yes, program execution. Program execution by the interpreter. Program execution by the interpreter. Interpreter. That's it. Program execution by the interpreter. See what's happened here. So first, this is compiler. Error checked by the compiler. If no errors, dot class file generated. The dot class file executed by the interpreter. See, this is compiler, this is interpreter. There are two things involving, right? Compiler, interpreter, two things involving. Suppose if it is Python, yes, only one step. Python, okay, some test.py, some Python script directly. Okay, directly Python interpreter working direct, only interpreter working, only interpreter. Yes, even C program also, only compiler working, only compiler. Oh, compiler generating exe file. Yes, generating exe file. Look after generating exe file. Yes, one second. Your main method don't have. There is an error. Main is compile. And yes, that exe file created and executed. Yes, compile will do everything in C language. Okay, but in Java, what happens here? There are two things involving. First, compile involving. Next part, interpreter. Errors checking by the compiler. Errors checking by the compiler. Errors checking by the compiler. But program execution by the interpreter. Okay. See, in Java, errors checking by the compiler. If no errors, it generates dot class file. Okay. Next, program execution by the interpreter. That's it here. That's it. Okay, right? I think you understand this is. Now, Java depends on what? Is it compiler or interpreter or both? Java depends on what? Is it compiler based or interpreter based or both? Tell me guys. Yes, come on. Java depends on what? As per this explanation, Java depends on what? Is it compiler only or interpreter only or both? Yes, you can share in the chat box. Chat box available or else you can speak it now. Yes, I have unmuted. You can speak it now. Okay, or else you can share in the chat box. Yes, both. Java depends on both compiler as well interpreter. Java, yes, Java depends on, yes, depends on both, depends on both both the compiler, as well interpreter, interpreter. Okay, interpreter, right? Now one very simple question for you guys. Okay, 1 second. This girl, Archana. Yes, 1 second. Yeah, this girl, Archana. Yes, you're online. Check your system. Design. Yes, this girl not able to listen. Yes, reason. Yes, he is in online only. Your network is okay, fine. But problem, check your system volume. Check your system volume or rejoin. Check your system volume or rejoin. Archana, do this. Okay, fine. Now let us continue. So Java depends on both the compiler as well interpreter. Depends on both the compiler as well interpreter. Okay, right? Yes, here very simple question for you guys. Very simple question, basic question, basic question. Can we create exe file in Java? Very simple question.
No, sir.
Yes, tell me
No,
what
sir.
you understand from this. From my last explanation, what you understand from this explanation? Have you seen anywhere exe file? See in these steps. First test.java, test.class file. Yes, in this process, anywhere .exe file. Have you observed any .exe? No .exe file. Okay. So in Java, we can't create exe, no exe file concept. See reason. Yes, see. Yes, answer is no. Because Java don't have exe file concepts. Yes, exe file concepts. Reason we'll discuss now. Very interesting topic now. Okay, Java don't have exe file concepts. See, any language, any language, any language program, any language program execution by the interpreter, execution by the interpreter. Yes, program execution, not error checking, program execution. If program executed by the interpreter, don't have exe file. Don't have exe file. Yes, don't have exe file. Okay, right? Don't have exe file. Yes, there's no exe. Yes, don't have exe file. Yes, any language, in any language, program execution by the interpreter don't have exe file. Don't have exe file. Okay. Yes. Here since Java program execution by the interpreter don't have exe. Don't have exe file. Exe file. That's it. Okay. Yes, in Java everything is dot class file. See in Java, yes, Java, yes, everything is a dot class file. Is a dot class file. See, dot class is different. Exe file is different. See, dot class file, yes, is not an exe file. Dot class file is not an exe file. Exe file is different. Dot class file is different. Yes, what is exe file? What is dot class file? Today topic. Now we'll discuss. Okay. See, exe file. Exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file. Binary code file, and it's a system understandable language. A system understandable language. It's a system understandable language. Exe file is a binary code file. It's a system. It's a binary code file. Okay. It's a system understandable language. Yes, what is dot class file? See, dot class file is a bytecode file. Yes, dot class file is a bytecode file. Bytecode file. Yes, and it's a JVM understandable language, not system understandable. JVM understandable. Okay, how that JVM understanding we'll discuss now. Dot class file is a bytecode file, and it's a JVM understandable language. JVM understandable language. It's a JVM understandable language. It's a JVM understandable language. Okay, fine. Now here about exe file, about dot class file, we'll discuss. Okay, fine. Now here, see. So all these basics. So all these basics here. Today topic Java depends on both compiler as well interpreter. Java errors checking by the compiler. If no errors, Java compiler generates dot class file. A dot class file is a bytecode file series. Java runtime by the interpreter. Program execution by the interpreter. The same what we discussed. Source code, bytecode, binary code, processor, then output. So this part is by the compiler. This part is by the interpreter. Okay. A Java depends on both compiler as well interpreter. Java runtime is a interpreter based. See any language runtime. Runtime is program execution. Program execution. Interpreter based no exe file. Yes, since Java runtime is a interpreter based no exe file concept in Java. Okay, can we create exe file in Java? No, no. We can't. Okay, there is no concept of exe files in Java. Okay, dot class file is not exe file. Okay, exe file is a binary code file. Next dot class file bytecode file. Okay, next here exe file is OS dependent. Dot class file is independent of platform. Now we'll discuss. Yes. Now about Java features. Okay. Yes. Now we can understand Java features. Till now what I discussed yesterday topic and today topic is the prerequisite. What is JVM? We'll discuss now. Java Virtual Machine. JVM means Java Virtual Machine. Today we'll discuss about it. Okay, today we'll discuss. See, now we can understand features of Java. So first one, independent platform. Let us start with this. Okay. Yes. Yes. Java. Yes. Java is an independent of platform. Independent of platform. Platform. What does it mean? Yes, what does it mean here? What does it mean? Yes. Independent of platform. Independent of platform means what? Yesterday explained about platform. Platform means what? It's a OS.
OS
means OS. Operating system. Platform means it's an operating system. Operating system. Okay. Yes. Here Java is independent of platform means Java program can run on any OS, any operating system. On any operating system. On any operating system. Okay, that's okay, fine. Java is independent of platform means yes, can run on any OS, can run on any operating system. Yes, that's okay, fine. Yes, now immediately question is how? Yes, Java yes made us independent of platform. Yes, independent of platform. Yes, this immediately question. Yes, independent of platform. Yes, let us see. Yes, now very interesting point. This is how Java made us independent of platform. How Java made us independent of platform. Let us see. That's very interesting topic. This now. Yes. So before going to this, let us see about exe file. Yes, about exe file. About exe. Here, some question for you guys. Some question. Exe file prepared on Windows OS. Exe file prepared on Windows OS. Question is exe file prepared on Windows OS. Can I run on Linux OS? Yes. What's your answer? Yes, anyone? Of course, I'll explain. Exe file prepared on Windows OS. Can I run on Linux OS? Say yes or no. Exe file prepared on Windows OS. Can I run on Linux OS? Exe file prepared on Windows OS. Can I run on Linux OS? Exe file prepared on Windows OS. Can I run on Linux OS? Yes, Ubuntu. Yes, that Linux can Ubuntu Linux OS or Red Hat Linux, any Linux OS. Answer is no. Answer is no. Is not yes. Exe file prepared on Windows OS. Can I run on Linux OS? No. Answer is no. Reason. Yes, reason exe file is a yes, exe file is an OS dependent. Exe file is OS dependent. Now immediately question, why exe file is OS dependent? Yes, why exe file? Why exe file is OS dependent? OS dependent, immediately question. Yes, this one we should answer. Why exe file is OS dependent? For this purpose, you must have the exe file knowledge. Yes, to answer this one, he must have the exe file knowledge. Now let us see exe file. Practically, I'll show what is exactly exe file. Okay. Yes. For example, here, for example, exe file. Exe means executable file. Executable. Exe means executable file. Okay. Yes. No, exe file. Yes. Bamidi Subramania, exe file works on OS with the help of MS Office. No, not MS Office. Exe file works Windows based exe file working on Linux base with the help of some third party tool. Third party tool required. Directly it won't work. Third party, there's a Wine software available. Wine software. Using Wine software, Windows based exe file we can run on Linux base. At the topic we'll discuss. Wait. The topic we'll discuss. See, exe file. So for example, C program exe file prepared on Windows base. Okay, prepared on Windows base. Then it contains what? It contains what? Let us see. So this is our C program. Okay, 1 second. Backend of this program. C drive. Yes, you guys don't worry about C program. Yes, I'm showing C program and Python scripting. Don't worry about this. Our topic is Java. So when you come to Java, how to install Java, how to write the Java programming, all the steps I'll explain very clearly. Only to understand about compiler, interpreter, exe file, these concepts, just I'm showing some C programs. Yes, that C software installed in my system, C software already installed, Turbo C installed. Okay, yes, Turbo C here in C drive, Turbo C installed. In Turbo C, there's a bin folder. In bin folder, all the C programs are there. Okay, what is this program here? Yes, math.cpp. Program is math.cpp. Yes, math.cpp. 1 second. Yes, yesterday's file. Let me delete that yesterday's file. Yesterday's file I'm deleting. Okay. No, this is CPP file here. Yes. Alt F. Saved. This is CPP file. 8:37 p.m. Okay. 16th June. 8:37 p.m. Just now it's saved. After saving now, compile. Success. Once you compile here backend, see math.obj file generated 8:37 p.m. See right click properties. Yes, .obj, it's object file. So what is this object file? This object file contains binary code for our C program. See this whole C program. Yeah, this whole C program converts into binary formats and write to that object file. Okay. Next, one more thing here. In this program, there are some header files. C library files, header files. stdio data, conv data, they are header files, predefined header files. These header files also having some binary codes. These header files also having some binary codes. These header files having binary codes. Next, your C program binary code. This is math.obj. Now, run. So when you try to run it here, select run option here. When you try to run it, yes, backend. See this backend. The exe file created. See properties. .exe file created. How that .exe file creates? Yes. Now here, C program exe file prepared on Windows for the contains what here. Okay. Yes. So first of all, yes, at the time of creation of exe file, what happens? Yes, creation of exe file, compiler generating exe file, right? At the time of creation of exe file, what happens? That compiler taking yes binary code for C program, binary code for C program. C program means that math.obj file, that math.obj file. Okay, math.obj file that contains binary code for C program plus yes binary code, binary code for yes C library. C library means like stdio data set file, conv data set file. Those header files already having some binary code, predefined header files. That binary code plus yes plus Windows OS library binary codes. Binary code. Yes, Windows OS, every OS is a library. See, in yesterday's class, we discussed. In yesterday's class, see this. Here, there is a library, right? Inside of OS, there is a library. Inside the OS, there is a library. Okay, that library. This library also in the binary format. Yes, all the predefined library inside of OS. This also in binary format. This library in binary format. Okay, by linking all of this in generating exe file. So binary code for C program, binary code for C library, and binary code for yes Windows OS library. So binary code, yes binary code for Windows OS library. By linking all of this in generates exe file. By linking all of this in generating exe file. Okay, so what's happened here now? C program that exe file linked with OS library, Windows OS library. Okay, exe file. Now here what's happened here? That exe file. Yes, exe file. Yes, linked with yes Windows OS library. Linked with Windows OS library. Yes, let us take one more example. Now, C program exe file prepared on Linux base. Then it contains binary code for C program plus binary code for C library plus binary code for Linux OS library. Linux OS library. Okay, right? Now let us see on Linux also. Let me show on Linux OS. Let me start Linux OS. Linux OS. Yes, in my system I have many setups. Yes, because I'm working yes, with different kind of technologies. So Linux. Yes. Now we can see on Linux OS practically. See here, 1 second. Windows OS, yes. See, Windows OS Turbo C. Backend compile, backend exe file, all thing happens in backend. Okay. Yes, in Linux, let us see manually. We are going to compile and we are going to create exe file in Linux base. You can see clearly in Linux base. See Linux base. This is a Ubuntu OS. It's a Ubuntu OS. Ubuntu Linux. Present working directory demo. PWD means present working directory. It's a demo. LS. Its contents. Suppose your mn directory is a cd change of directory mn change the mn present working directory mn its contents. These things are there. Okay. Remove. Yes, all are removed. Now it's empty directory. Yes, you guys don't worry about Linux commands. Our topic is not about Linux commands. Okay, you guys don't think about what is PWD, what is LS, what is CD, what is RM-RF. You don't worry about it. This is not our topic. Our topic is about exe file. Now let us see what is exactly that exe file. Gedit Yes, test.c. See, gedit is like a Windows notepad. Yes, Windows for is notepad and program file, right? Same here, gedit. Gedit means editor. Okay, gedit test.c. The test.c file opening. Yes, opens. Here I'm writing hash includes stdio.h. Okay. Yes, next void main function. Yes, starting ending. Yes, this. Yes, int a is equal to 10. Okay, next. Yes, int b is equal to 20. Okay, fetch int c declared c is equal to a plus b. A plus b. Okay, yes, printf. Yes, printf. Yes, addition. Yes, addition equal to percentile d slash n comma c. So addition is page. Addition, subtraction, next multiplication. C equal to a plus b, c equal to a minus b. No subtraction. Subtraction. Okay. C equal to a into b. A into b. Okay. Next multiplication. Multiplication equal to. Okay, done. Save. Save and close. ls c test.c. Now this program we have to compile. GCC means C language compiler. GCC-C test.c. C means only compile option. C means compile. -C compile option. Test.c compiled. C. Here also same test.o file generated, right? Object file. .o means object file. Just like Windows. Windows.obj file. Windows.obj. Like that here also .o file. These are same object file generated. Object file generated. Okay. 1 second. Remove start.o. Deleted the .o file. Yes, gedit test.c. See, yesterday topic compiler shows all errors from top to bottom, right? Yes, let us see that. Yes, yesterday's topic. Save. See, GCC-C test.c. See this. Compile displaying all errors from top to bottom. 10th line error, 12th line error, 14th line error, 18th line error, 25th line error. Yes, compiler shows all errors from top to bottom. Is yesterday's one. Okay, compiler shows all the errors from top to bottom. Okay, let us correct all the mistakes. Semicolon missing here. Yes, here. Comma missing. Okay. Yes, next here. Double quotation missing. Okay, next here. Semicolon missing. Save. Control yes, save. Yes. ls. Now GCC-C test.c. Yes, compile no errors. If no error, not generated object file. That object file generated. After generating the object file, now you have to convert into exe file. Yes, GCC-O. Yes, exe name is, let us say, projects. S.o. Okay, not GCC. Yes, that's compiler. Okay, it converts .o file, object file into exe file. The result exe is project exe. Project exe. ls. See that. Project green color means it's exe file. Green color means exe file. Now let us run it. That exe file we should run it. Project exe file. Yes, executed, then get the output, right? This project exe, it's exe, this exe file. Okay, let me show that gedit projects. Yes, is opening. Exe file contains what? Binary codes. Exe file contains binary code. That project exe. That name can be anyone. See this. That project exe file. Binary code, zeros, ones format. Machine language. System understandable language. System understandable language. This is machine language. Okay, fine. Now here Yes, project exe, right? That result exe name is project exe. That result exe, project exe. Suppose if you want another name also. Suppose Durga. Ls. That exe name Durga. Okay. Dot slash Durga. Let us run it. Yes, addition, subtraction, multiplication. That's it. Okay. Now what is this exe? This exe file contains what? What happens at the time of creation of exe file? So what happens here? Now GCC, C language compiler, it will take your binary code for your program, C program, binary code for C program, test it dot to a file, binary code for C program, plus binary code for C library. In test.c also included header file, right? std header file included, binary code for yes, that header file, plus binary code for Linux OS library. By linking all of this, it generates the exe file. That project exe file contains what? Yes, that exe file, C program exe file prepared on Linux base, then it contains binary code for C program, means that test.o file, test.o code, plus binary code for C library, means std header file, binary code. Next, binary code for Linux OS library. Linux OS library, binary code for Linux OS library. By linking, it generates exe file. Yes, let me show that. 1 second. In Linux, yes, there's a file command. File command is to check the type of the file. See test.c. Yes, file command. File command to check the type of file. What is test.c? Test.c. C source ASCII text. Yes, it's a C source program ASCII text. Now, project, file, project. See that project. What is project? It's executable file. Project is a executable file. Okay, it's a yes, x86 means 8086 processor. That exe file generated on 8086 processor. My system using 8086 64-bit OS. 64 means 64-bit OS. That Linux OS is 64-bit OS. Okay, next series. ld-x86-x86-64.so2. .so means it's a OS library. .so is an extension for the OS library. .so is an extension for OS library. .so dot means second version. For this library, second version. Second version of that library. Now this is Linux library. Linux OS library. So project exe file contains what? Linux OS library. So Linux OS library linked with that exe file. That's it. Okay, that project exe file yes contains now yes Linux based library, C program exe file prepared on Linux base, then binary code for yes Linux based library. Now here exe file linked with what? Linux base. Here exe file linked with Linux based library. That's it. So every time of generating exe file, that is linking with OS library. Okay, suppose one more example. Suppose if it is C++ program exe file prepared on Windows OS, C++ on Windows OS, then it contains binary code for C++ program. Okay, binary code for C++ library. Next, binary code for yes Windows OS library. Binary code for Windows OS library. Windows OS library. Okay, Windows OS library. That's it here. Now what's happening here? Here exe file, that C++ exe file, is linked with Windows OS library. So here whenever generating exe file, that exe file is always linking with OS library. Okay. So what happens here? Exe file is linking with OS library. Yes, at the time of generating. At the time of generating exe file. Yes, it is called as static linking. It is called as statically statically linking. Statically linking. Okay, that OS library statically linking with exe file. See, in previous class, see, every program has to link with OS library before going to execution. Every program has to link with OS library. See here, C and C++, these programs linking with OS library statically at the time of creation of exe file itself. At the time of creation of exe file itself, linking, statically linking. Okay, yes. One second. This guy is yes, Subramaniam. Yes, we are using Windows OS. No, then how we are using Linux OS? How this possible using both yes OS at a time? Yes, here Windows OS, on top of Windows OS, I have installed VirtualBox, Oracle VirtualBox. In VirtualBox, Linux is available. In VirtualBox, I have installed Linux OS. That's the reason both at a time we are using. Okay, here one Linux. Next, see, totally 1, 2, 3, 4, 5 Linux computers running in my system. One Windows and 5 Linux is running. That VirtualBox, inside of VirtualBox, I have installed Linux OS. So that's the reason I'm using both. See, Linux is running, so Windows running. On top of VirtualBox installed. I think clear, right? On top of VirtualBox, it's installed. VirtualBox on the Windows OS, on top of VirtualBox, Linux installed. Okay, yeah, fine. I hope it's cleared. Okay, yes. So that exe file, statical link, it is called a statical linking. Okay, now let us see how exe file working on different operating systems, different platforms. Okay, working of exe file on different platforms, different platforms. Okay, suppose for example here, for example, yes, test.exe file, for example, test.exe file prepared on Windows OS. Then it contains yes, Win library, that Windows library. Okay, yes, now test.exe file with the Win library on different operating systems or platforms. On different platforms on different operations. Let us see. Now let us take different platforms. How it's working. Different platforms. See. Yes, your computer. Yes. Yes, here it's a hardware. On top of hardware, this is a OS. See, previous classes we discussed about this. On top of hardware, yes, operating system running OS. Yes, now Windows OS. Yes, Windows OS, Windows with Win library. Now test.exe file on this Windows OS. Okay, hardware on top of hardware, this OS layer on top of OS. Now the test.exe program, test.exe file. See, when you try to run this test.exe file on Windows OS, what happens here? This when you try to run test.exe file on Windows platform, what happens? Now this test.exe file, yes, it will try to call to Win library. Yes, it will try to call to Win library because already linked with Windows library. Test.exe file, yes, with Win library. Test.exe with Win library. Okay, now that test.exe file, it will try to call to Windows library. By calling, it has to communicate with the hardware. To communicate with hardware, OS library required compulsory. Okay, with the help of OS library, that programs will communicate with the hardware. The topic we discussed previously. Okay, now test.exe file call to Windows OS library, call to Windows library, call to Windows library. Yes, here Windows library is available. That required library is available. Using that library communicates with hardware components. Yes, successfully executing that program. That program executes successfully. That program executes successfully. Now let us take another platform. Another platform. Yes, Windows. Next, let us take Linux platform. Okay. Now Linux OS. Linux OS with Linux library. Linux library. Linux library. Now same test.exe. See this. Same this test.exe file. Placing on Linux base. Now try to run it. When you try to run it here, now this test.exe will try to call Windows library because test.exe will already linked with that Windows library. Static elements fixed. That link fixed. That never changes. That link fixed. Never link is fixed here. Never changes. Now this test.exe file it will try to call to Windows OS library, but not available. Library is not matching. Library is not matching. Library is not matching. So try to call to Windows library here, but here is not available. It fails. Simply exe file fails. That test.exe file fails because that library is not matching. That OS library is not matching. Not matching, simply it fails. Okay. Yes, same thing. Let us take another platform. Suppose Mac OS. Let us take Mac OS. So Mac with Mac library. Yes, Mac means Macintosh. Mac is something like a Linux base. Mac is, if you know Linux base, Mac is very simple. Okay, yes. Now test.exe file. When you try to run test.exe file in Mac base here, now it will try to call Windows library, but he is not available. Not of that Mac library. So OS library changes. So again it fails. Again it fails. So then what happened here? Exe is OS dependent. Okay, simply exe fails to run other operations. It will run on only Windows operating system. That's it here. That's it here. Okay. Yes, since exe file, yes, linked with OS library, OS library. Yes, it's a OS dependent. It is OS dependent. That I think it's clear. Since that exe file is linked with OS library, it's OS dependent here. That's the reason. Now here, let us go to back. Here, exe file. Yes. Why exe file is OS dependent? Yes, simple answer. Yes, it contains OS library. It contains OS library. It contains OS library. That's it. Now, so this is about exe file cleared. Exe file is cleared. Now let us go to Java. Yes, Java. Yes, first let us see about Java .class file. How Java program made us independent platform. Let us see. Now Java yes, come to Java. Yes, in Java, same example. Let us take this example. Same example. Now Java. Okay. Yes, now Java program. Java program .class file. Java program no exe is a .class file. Java program .class file prepared in this way. Then it contains binary code for not binary code, it's a byte code. Byte code for Java program. Byte code for Java program plus byte codes. Byte code for Java library. Yes, Java's is a library, Java library. Next, binary code for OS library. No, don't have this part. Okay, just only byte code for Java program plus byte code for Java library. That's it. Byte code for Java program, byte code for Java library. See, Java library also developed in Java. Java library also developed in Java. Okay. See, C library developed in C language. Python library developed in Python. Java library developed in Java. Okay. So it's a bytecode for Java program. Okay, so bytecode for Java library. That means it's a pure Java program. So you get dot class file. So you get dot class file. Dot class file is a pure Java program. Pure Java program. Pure Java program. Pure Java program in byte format. In bytecodes. Okay. Yes, it don't have. Yes, it don't have any voice library. Don't have any voice library. Don't have any voice library. So dot class file is free from voice library. Free from voice library. So this is dot class file. So exe file contains voice library, but dot class file don't have any voice library. Yes, dot class file is free from voice library. Okay, free from voice library. Okay, that don't have any voice library. Now let us see. Suppose tested dot class file. Tested dot class file. Tested dot class file. Yes, working on different platforms. Working on different platforms. Different platforms. Yes, how it's working on different platforms. Now let us take different platforms here. Yes, first Windows platform. Yes, Windows platform. Okay. Yes. Now test dot class file. Okay. Now tested dot class file placing on Windows OS. Okay, tested dot class file. Tested dot class file. Okay. Now tested dot class file. This tested dot class file is moving onto Windows OS, placing on Windows OS. Now, can I run it directly? Now running tested dot class file. Now to run this tested dot class file, first of all, it has to link with OS library. Otherwise, cannot communicate with hardware components. It has to link. See, previous class. Every program has to link with OS library before we start execution. Compulsory. Now, dot class file you cannot run directly. Yes, first of all, it has to link with Windows OS library. After linking, then execution starts. But here don't have any link. So dot class you can't execute directly. Yes, this dot class you can't execute directly. Now this dot class file has to link with Windows OS library. Yes, who will link it? Who will link it here? For linking purpose, between dot class file and Windows OS library, yes, one more layer comes. Yes, what is that layer? Yes, between dot class file, Windows OS, one more layer comes. For linking purpose, one more layer comes. What is that layer? Anyone can you guess it? What is that layer? Anyone can you guess it? Between test.class file, Windows OS, one more layer comes. Here one more layer come to picture. So what is that layer? What is that layer? Anyone can you guess it? That layer is a JVM, Java Virtual Machine. Now Java Virtual Machine come to picture. Now JVM taking this dot class file, Java Virtual Machine, JVM taking this dot class file, linking with Windows OS library, links with Windows OS library. Once linked with Windows OS library, then communicates with the hardware. That's it. Over. Now, same dot class file on another platform. Same dot class file on another platform. 1 second. Same dot class file on Linux platform. Same dot class file Linux base. Now Linux with Linux library, Linux with Linux base library. Linux with Linux base Linux library. Now here, what happens here? Same the dot class file. Same this dot class file moving at Linux space. After moving in Linux space, on Linux space there is JVM. This Linux JVM taking tested dot class file, linking with Linux base library. Of linking then communicates with hardware. Yes. Same dot class file working on Linux base also. So what is happening here? Yes, if it is OS is Windows OS, the dot class file is linking with Windows OS library. Next OS changed. Now JVM taking dot class linking with Linux based library. So whenever OS changes, that link changes automatically. Okay, see here for the initially, yes, JVM taken test dot class file linked with Windows OS library. Next same test dot class file taken with JVM are linked with Linux based library. Okay, now another platform, suppose Mac OS. Yes, Mac OS. Mac OS with Mac library. Mac library. Yes, here the same thing happens. On Mac OS also this JVM. Yes, Mac JVM. That JVM taking dot class file and linking with Mac OS library. Once linked here, communicates with the hardware. That is successfully working. Now what happens here? Here Java dot class file. So every time of changing ways that link changes, means dynamical linking. This is called dynamical linking. Previously C and C plus CXE files. Statically linking. Statically means fixed. Static means fixed. So once linked, that link never changes. But in Java, yes, dot class file don't have any OS library. It's a free from OS library. Okay. Get the dot class file. Every time of changing OS, that link changes. So you get dot class file. Yes, see dot class file. Yes, links to yes, OS library. Yes, OS library dynamically by the JVM. Okay, so every time of changing OS here, for every time of changing OS, changing OS, link changes. Nothing but it's a dynamic linking. Dynamically. So dynamical means runtime. That runtime link changes dynamically. Okay, dynamically. Right, dynamically changing here. Okay, since dot class file is dynamically linking to different operating systems here, it's an independent platform. That's it here. Okay, that's it here. How dot class file is independent platform? Reason, yes, since dot class file, linking to since dot class file, yes, linking to different operating systems, different operating systems dynamically, by the JVM. Yes, it's an independent platform. Dynamically by the JVM. Okay, by the JVM. Yes, it's an independent platform. Yes, it becomes independent platform. It's an independent platform. Independent. Yes, independent. Yes, independent platform. Independent platform. Right, independent platform. Now here, JVM is responsible to make the Java as independent platform. Finally here, JVM is responsible. Yes, so JVM is responsible. JVM is responsible to make Java as independent platform. Independent of platform. Right, independent platform. Okay, right. Yes, that's it here. See, there are two things. Why exe file is OS dependent? Okay, how dot class file is independent of platform? These 2 points. Why exe file is OS dependent? How dot class file is independent of platform? Okay, there are 2 questions here. So question one, why exe file? Why exe file is OS dependent? First, platform dependent. Okay, platform dependent. First question, platform dependent. Okay, so why XFL is platform dependent? First question. Second question here, question two. Yes, how Java program, yes, made us independent of platform, independent of platform. These two questions we should answer finally here. Okay, right, we should answer these two questions. Okay, so first one, yes, first one, what is answer? Why exe file is platform dependent? Yes, exe file links with OS library statically. Good. Yes, exe file statically linking with OS library. That's the reason. Yes. How Java program made us independent of platform? Yes. How? Yes. Dot class file. Not dynamic. That word you have to present dynamically. Yes, dynamically linking with OS library. That's it here. Okay, that's the difference here. That is static linking, this dynamic linking. Okay, see, even Python scripting also dynamically linking to OS library. Python scripting also independent of platform. Reason Python scripting also dynamically linking to OS library. That's it. That is dependent, OS dependent, independent. Yes, platform dependent, independent of platform. Difference here. Okay, see, wherever exe file concept is, that is OS dependent. Okay, yes, if not of non-exe form means it's independent of OS. That's it here. Okay, statically linking concept is a OS dependent. Dynamical linking means independent. That's it here. Fine. So this is independent of platform. Yes, platform dependent. Okay, now here one interesting point here. Java program is an independent of platform, independent of OS. But JVM is a OS dependent. Java program is independent of platform. Interesting point. Java program is independent of OS, but JVM is OS dependent. Reason JVM is a C++ exe. JVM developed in C++. JVM is a C++ exe file. JVM is exe file. Okay. Yes. See, different JVMs. One second. JVM is a C++ exe file. Okay. Now here question is here some question. One more point here. Yes. On Windows-based JVM, Linux-based JVM, Mac-based JVM. So is it part of OS? See, you see, I'm explaining on every way. This is JVM, here JVM, here JVM, here JVM. Is it part of OS? No. JVM is not a part of OS. Okay, JVM. Yes, JVM is not a part of OS. JVM is not a part of OS. Yes, it is from JDK. It is from JDK software. It's from JDK software. It is from JDK software. JVM is not a part of OS. It is from JDK software. Then, yes, to get JVM, Java virtual machine, to get JVM on operating system. How to get JVM on operating system? To get JVM on operating system, yes, JDK software should be installed. JDK software should be installed. So once installed JDK software, you can get JVM. That's it here. Okay, Windows-based JDK you have to install. Linux-based JDK you have to install. Okay, so whenever you want to run your Java program, you have to install JDK. Without installing JDK, you can't get JVM. that yes, to get JVM on operating system, a JDK software should be installed. Once installed, we can get the JDK. Okay, right? Now here, JVM is not a part of OS, it's a part of JDK. That's okay. See, JVM, yes, JVM. 1 second. Is it point? Yeah. Here, 1 second, 1 second. Yes, here. This is okay. JVM is not a part of it from JDK software. Okay, fine. Now, JVM is a C++ exe file developed in C++. But JVM is exe file. So JVM is OS dependent. See, since JVM is OS dependent. Yes, JDK also OS dependent. JDK also OS dependent. Okay, see, Sunsoft. Yes, Sunsoft developed. See, Sunsoft has developed yes different JVMs for different JVMs for different operations. Okay, same JVM cannot use on different operations here. JVM changes. Okay, Sunsoft has developed different JVMs for different operations. See, Windows JVM is having knowledge of Windows OS library, so it can link .class file with Windows OS library. Linux JVM is having knowledge of Linux OS library, so it can link here, right? Now, Mac JVM is having knowledge of Mac OS, it can link to Mac. See, I think one more interesting point here, JVM is exe file, right? If it is Windows based exe file, that exe file contains what? Tell me guys. Yes, Windows based JVM exe file contains what? Windows OS library. See, inside of JVM already library is there. Inside of JVM already library is there. Yes, JVM with Windows OS library. Okay, I think you're understanding. JVM with library. Which library? Windows library. Now this JVM with library means Linux library. Okay, this JVM with library means Mac library. See, exe file, JVM is exe file. Yes, Windows based exe file linked with Windows library. Inside of JVM, already Windows library is there. Okay, yeah, this JVM, inside this JVM, already Linux library is there. Okay, yeah, this JVM, already Mac library is there. Yes, already it's having library. So JVM knows about Windows OS library. This JVM knows about Linux OS library. Yeah, this JVM knows about Mac lib. So that JVM is having knowledge of OS library. Since having knowledge of OS library, it communicates with OS. That's it here. That is what is happening here. Okay, right? So that's the reason independent of platform. Okay. Now since JVM is OS dependent, JDK also OS dependent. JDK also OS dependent here. OS dependent. See JDK software, C drive. Here this is JDK software. See, this is Windows JDK. Yet this Windows JDK cannot install Linux OS. For Linux OS, separate JDK requires. Linux JDK. Linux JDK. Java C. Yes, this is Linux JDK. Open JDK 9 JDK. This is Linux JDK. This is Linux JDK. Linux JDK. Next, this is Windows JDK. So you get different operating systems having different JDKs. Yes, let me show that. Downloads JDK 1.8. See, SE JDK. See JDK. So downloads, all the JDK downloads. Okay. Yes, JDK for Linux OS, JDK for Mac OS, JDK for Solaris. So JDK for Windows OS. Yes. Now in our Windows systems, Windows 10, we should download last one. Windows 64-bit OS. Windows 64-bit last one we should download it. Yes, you guys don't worry. You need not to download here. Yes, I have provided in Drive. In Drive, it's available. JDK available, Eclipse, everything is available. You don't worry. Yes, to download from this Oracle site, you must have the Oracle account. Oracle account, otherwise you cannot download. Okay, see, when you try to download it, ask for the account. Yes, I reviewed, download. Yes, it asks for the Oracle account. See that Oracle account. Yes, I have the account already. Okay, it's downloading. I'm using regularly this Oracle account. Okay, see, it's downloading. Okay, yes, you guys don't worry. You need not download here. I'll provide it. Yes, I'll provide all these softwares. Okay, yes, don't worry about it. Yes, okay, fine. So this is how Java made us independent platform. Yes, 1 second. Last point, last 5 minutes topic. See, exe file dot class file differences. Exe file and dot class file difference. See, what is exe file? It's a binary code file. Yes, I showed zeros ones format. Exe file is a binary code file. We have seen on Linux base, right? Binary code file. Dot class a bytecode file. Yes, what is bytecode? Once enter into Java programming, I'll show bytecode. After entering into Java programming, I'll show bytecode. Exe file is a binary code file. Dot class a bytecode file. Exe system understandable language. Dot class JVM understandable language. Okay. Next exe file. Yes, it contains program codes, software library, and voice library. Yes, exe file is voice library. Yes, dot class pure Java program don't have voice library. Main difference, exe file is voice library, dot class file no voice library. Pure bytecode, that's it. Okay. Next, exe file is prepared file specific operating system. Exe file is a prepared one, means statical linking. Because of statical linking, prepared for specific OS here. But dot class is not a prepared file. Yes, you don't have any OS library. It's not a prepared file. See, OS library statical linking with exe file. Yes, here OS library dynamical linking with dot class file. Okay, so exe file is already prepared one. Okay, already prepared. Okay, means statical linking. Again, linking is not necessary. Already prepared. But dot class is not a prepared. After moving on to OS means after placing an operating system, now JVM links to current OS. So it's a dynamically linking. This is the statical linking. That's it. See, exe file executes faster than dot class file. Reason, already prepared file. Again, preparation is not necessary. Next, one more thing, binary code file. Exe file is a binary code file. So system can understand binary code directly. But when come to dot class file code, byte code first of all converts into binary code. That binary code linking to voice library. Yes, byte code converting into binary code, time taken. At runtime converting into binary code, time taken. So little bit slow. Dot class file is little bit slow compared to exe files. That's it here. That's it, right? Next, one more thing here. To run exe file, yes, application software not required to install. Suppose, for example, here Linux OS, Ubuntu Linux OS. On Ubuntu 3 exe file prepared. Suppose on Ubuntu 3, C software installed. Here GCC C compiler installed. C compile installed and exe file created. That project exe file created. Now this project exe file you can move to another Ubuntu. Same ways, not different Linux. Same Ubuntu ways. Another Ubuntu ways. And you can run that exe file directly. Again, C software not necessary to install. Again, that software not necessary because exe file is already prepared one, ready to execute. Again, C software not necessary. Directly that exe file can be executed because already prepared file, prepared as per the OS, prepared file, not necessary. That C software not necessary. C software not necessary. To run exe file, application software means that C software not required to install. But to run dot class file, JDK should be installed. So what dot class file prepared on Windows OS and executed, tested, successfully working. Same dot class file, move on to Linux space and try to run it. No, you can't run directly. There JDK required. On Linux base, you have to install JDK. Okay, that Java software should be installed here. To run dot class file, Java software you have to install. That's it here. Suppose exe file. To run the exe file, C software not necessary. Once exe file created, C software is not necessary. Okay, but in Java, dot class file, every time of running dot class file, JDK required compulsory. Without JDK, cannot run it here. That's the difference between exe file dot class file. Yes, that's all about independent platform and exe file dot class file. I hope everyone you understand clearly this topic. Is it clear, guys? Hello.
Yes, sir.
Is it? Yes. 1 second. See, this topic, no trainer will explain like this. I am sure. Yes, in the world, no Java website will provide information like this. No chance. Okay. See here, to explain about this topic, I have taken two classes prerequisites. Okay. Yes, first explain about OS, next explain about exe file, next explain about dot class file, next explain about interpreter, compiler, low level, high level, all the basics explained, right? After explaining basics, yes, I started this independent platform. That is my way of explanation. Okay, so before going to start any topic, first of all, I'll finish all prerequisites. After finishing prerequisite, I'll touch the topic. There's a link between the topics here. That is my way of explanation. So everyone can understand my topics very clearly because of this way of linking between topics. I'll maintain that kind of link here. Okay. Next, one more thing. My knowledge is different from others. Okay. You can't compare with anything, any trainer. Yes, I worked in embedded C. I have very good experience in embedded C, and I have very good experience in Linux base. Okay. Next, very good experience with Java and Hadoop. Various kind of skills I have. This is all that my experience. I think you understand. Yes, the way of class experience tells experienced or not. The trainer is experienced or not depends on way of experience tells that here. Okay. Now, same concept just to try in Google. Just nowhere will get this much of information. Okay. Next, just you search for this difference between dot class for exe file. Try for this difference. Yes, in Google, just to try exe file dot class file differences. No, you cannot see anywhere. Yes, no site will give this much of information clearly like this. Okay, so my knowledge is different. My way of explanation is different. Okay, my experience is different here. Okay, my experience is more than the industry, more than the software industry. Okay, even Google also will not give that kind of information. Yeah, that is my level. My profile is like that. Okay, yeah. So that's all for today. I hope everyone understanding classes very clearly. Going forward, once programming started, I'll explain very slowly, clearly, neatly, and very interesting classes. Okay, going forward, you'll see a lot of interest, day by day increasing interest. Okay, yeah. So that's all for today. That's all. Tomorrow topic, Java installation and Eclipse installation. Tomorrow going to start, yes, Java programming. Yeah, that's all for today. I think no doubts. Yes, if no doubts, then better to wind up for today. Okay. Yes, 1 second. Yes, in anyone not in WhatsApp group, share your details. Yes, WhatsApp. Yes, already communicating the WhatsApp with every student. This is my WhatsApp number. Okay, share your name and Gmail ID. Yes, your name and Gmail ID. Yes. Yes, even for some students, even software shared, document shared. Yes, drive access also given to some students. Drive access also given to some students. Okay. Yes, I think more than 12 to 13 members drive access given already. Okay. Yeah, this is my WhatsApp number. Still anyone pending, share it, share these details. I'll add to group. Yes, in group. Yes, I think 30 members, around 30 members are there in group. Yes, group already created. Okay. Still anyone share these details. I'll add to group. Yes, at your convenient time you can share it. Yeah, that's all for today. That's all. So let us wind up session for today. Let us wind up. So thank you guys. See you tomorrow. Yes, this is WhatsApp number. Yes, I'll wait for 1 more minute. Yes, this is your group. 8 p.m. Yes, already communication is going on. Yes, how many students have group? Yes, 25 students already shared the details. Yes, 25 students share details. Almost 18 members paid fees. Already 18 out of 25, 18 members already paid fees. Okay, yeah. Yes, that's all. That's all for today. So thank you guys. See you tomorrow. Thank you. Tomorrow also same link, same time.